All right, so let's just get a little solid with those concepts because it's a little weird with the negatives. We're on page 557, section 10.3 of your book. I want to look at, what do I want to look at? I want to look at number 2D, and this one just says, plot each point with the given polar coordinates and find the corresponding rectangular coordinates, okay? So I do want you, I'm going to assign you some of these, and I do want you to plot them, use the graph paper that I posted and plot them. So I'm going to do D. It's 2 square root 3, 2 pi over 3. So where's 2 pi over 3? It's here. Where's 2 square root 3? Well, you can use your calculator to get approximation. Square root 3 is 1.7. 2 square root 3 is going to be approximately 3.4. So 1, 2, 3.4 roughly here. So we'll just plot that point there. And maybe we'll put a D by it since it was point D. And we'll label it 2 square root 3, 2 pi over 3. So this is, just to get used to where these things are on this polar coordinate plane. Now the other thing they want us to do is find the corresponding rectangular coordinates. So to do that, we actually have to calculate. So I have the point r theta equals 2 square root 3, 2 pi over 3. And so we're going to use the formulas x equals r cosine theta. You just want to be really solid with these, and y equals r sine theta. So this is going to be our r, which is 2 square root 3. Yes, times cosine of 2 pi over 3. Do yourself a favor and try to evaluate these without a calculator. What is the cosine of 2 pi over 3? Let's see. I always think of it like this. Since its cosine is the x coordinate, I'm in 2 pi over 3 is over here. So that's going to be the short one. It's negative 1/2. So that's 2 square root 3 times negative 1/2. It's negative square root 3. All right. And what about the y coordinate? The y coordinate is r sine theta. So that is 2 square root 3 sine of 2 pi over 3. So then just looking at the same here, sine 2 pi over 3, it's the tall one and it's positive. Like that's how I think of that. So that is 2 square root 3 times the tall one is square root 3 over 2. So that's going to equal 3. Right, so the coordinates, so I want to write the x coordinates are negative square root 3, comma 3. Yeah. I expected it to be nicer than that, but whatever. There's some 30, 60, 90 triangle involved. I wanted it to be something, I guess, yeah, because this is this. So this is the, do I really need to think about this? This is the long leg of the triangle. This is the short leg of the triangle. In a 30, 60, 90, the long leg is square root 3 times the short leg, which it is. Nice. All right, that's 1D. Now, the other ones I wanted to just demo quickly here are number 14 and 16. So not number 14 and 16 yet. I want to do number 3, B and D. So let's start with B. So B is the point 1, negative square root 3. All right, it says to plot the point. So if you want, grab a nice coordinate plane and do that, but you don't need to do that. You can just sketch a graph like this, because the crucial thing is to know which quadrant you're in. So 1, negative square root 3. Here's 1, negative square root 3 is going to be down here somewhere, and there's the point 1, negative square root 3. So that's all you have to do for the graph. You don't have to make a fancy graph. All right, so now we're going to say what r is. So r is the square root of 1 squared plus negative square root 3 squared. I mean, if you want, it's just 1 plus 3, so it's 2. And then theta is the inverse tangent of y over x, so negative square root 3 over 1. Try to do that without a calculator. If I think about the unit circle, I want the slope, I want the tangent to be negative square root 3. Let's make my negative a little clearer there. I want the tangent to be negative square root 3. So that's I want it to be sloping down, and that's the steep slope. So negative square root 3 is going to be like 2 pi over 3 is going to have negative square root 3 for a tangent, right? But also, if you do it in your calculator, what you're going to get is negative pi over 3, because the restricted domain for inverse tangent is negative pi over 2 to pi over 2 for tangent. So your calculator will return this as negative pi over 3. But remember, you got to think about what quadrant that we're in. Okay, so in fact, we are in quadrant 4. All right, so this is negative pi over 3 because negative pi over 3 is a quadrant 4. So we can say that the point is 2 negative pi over 3. But wait, look what it says here. It says find 2 sets of corresponding polar coordinates. So again, every point on the polar coordinate plane, and this is one of the challenges of the polar coordinate plane, every point has infinitely many representations. So we could also call this what? We could do 2 pi plus negative pi over 3, you know, whatever that ends up being. What is this? This is 2 pi over 3, 4 pi over 3, right? 4 pi over 3. Is it 5 pi over 3? I think that's 5 pi over 3. Yeah, because then this would be 6 pi over 3. So, or 2 5 pi over 3, right? Many representations. You could call it lots of other things too. You could call it negative 2 pi over 3, right? Negative 2 pi over 3. There, I give you 3. I give you a bonus, 50% bonus on that question. All right, so that's just getting the polar coordinates from the rectangular coordinates, the rectangular coordinates from the polar coordinates. I have in my notes that I also wanted to do number 3D. Do I want to do 3D? I mean, why not? It's negative 1, 0. So number 3D, I think I can squeeze it down here. The point is negative 1, 0. So I can just do a graph like negative 1, 0 is right there. So I could be cheesy like this and say, look, it's pretty clear already that the r is pi and the theta is pi and the r is 1. So, all right, this is, so that's why this is worth talking about. It's 1 pi, just from looking at the graph, right? If I draw a circle here, radius 1, happens to lie on the circle. So I already know that the r is 1 and the theta is pi, right? So what will be another representation? 1 negative pi. Boom, I didn't even really have to do anything. It's nice if I support that with r equals, I mean, it's nice to just show that it works. Square root of 1 squared is 1, plus 0 squared is 0, square root of 1 is 1. All right, what's the inverse tangent of 0 over negative 1? Inverse tangent of 0 is 0, but 0 puts us in the wrong quadrant. Actually, the wrong, it puts us on the wrong axis. So theta equals 0 is going to be over here. So see how inverse tangent can give you the wrong angle. And you have to look at the graph and say, okay, but it's really a different angle. It's pi. It's the other angle whose tangent is 0. So, but on negative x-axis, that inverse tangent of 0 is really pi. And that's how we get the 0.1 pi. So that's thinking about the quadrant that you're in, or in this case, the quadrantal angle that you have. See, some of these axes are sometimes called quadrantal angles. But another nice thing about this number 3D is that the quadrantal angles are pi over 2, 0 pi over 2, pi, 3 pi over 2, and all their coterminal angles. Right. So there's a lot of nice things actually lurking in this one. It is a quadrantal angle whose calculator-based inverse tangent is going to be misleading. So you have to think about what quadrantal angle you're on. Also, it's a problem that you can answer directly just by looking at the graph. You couldn't do that for this one. There's no way you would know from looking at these coordinates that this would be negative 2 pi over 3. All right, so there's some just polar and rectangular plotting and converting. Next up, we're going to start looking at, okay, now we've got r and theta on a graph, just like we used to have x and y in a graph. And then what we did with x and y in a graph is we started saying, okay, what if y is a function of x? And all kinds of things happen, right? Now we're going to say, what if r is a function of theta? And then all kinds of other things are going to happen. And that is what we're doing next.